So determine for me, that's the first one. Determine the constant that should be added to this binomial to create a perfect square trinomial. So what's my recipe for that? It is. It's half of b squared. So the number that's going to go there should be half of b squared. What's half of b? Negative 3/10, exactly. So negative 3/10 squared is what? 9/100. Yeah. Okay. And so what would the trinomial be then? Well, I'm just going to add that third term, right? Duh. Okay, that's no big deal. Now, next part. What would be, if I factor this, what's the number that's going to be connected to the x when I factor this? Negative 3/10, half of b, right? So whatever number was inside, that's the number that's going to be the magic number that shows up twice. Okay? Make sense? Good, good. Okay, how about one like this? Rewrite the equation in vertex form. So remind me real quick, what is vertex form? X minus h squared plus k. Good. Okay. There's vertex form. So you could do this by the methods of last unit if you really want to, right? How would I calculate h directly? What's my formula for calculating h? Come on now. Negative b over 2a, right? So I could do that, right? I could just say h equals negative b over 2a, and k is what? What do we do to find k? Come on, people. I'm just trying to find a y coordinate. I just plug the x coordinate in, right? It's just f of h, right? So we could do that. That's what you guys did last unit, okay? Or we could do what we're kind of probably supposed to do. Either one's fine though, I don't care. We could complete the square. Okay, so I could put this into vertex form by completing the square. What would the steps be to complete the square here? Subtract 3 to the other side. So we're going to get y minus 3 equals, I'm going to leave myself a little space there, right? X squared plus 4x. Okay, now what am I going to... 2 squared. Half of 4 is 2, so I'm going to add 2 squared to both sides, which is just 4. And I have to treat both sides equally, right? So I'm adding 4 to both sides. Okay, that means that the right side is just going to be, what's the number that's getting attached to x? 2. Aha. Okay. And on the other side, what do I get? Y plus 1. Okay, so then what's my final answer? Y equals the quantity x plus 2 squared minus 1. There you go. Okay, good. Either way, I don't care. That's probably quicker, don't you think? To just complete the square. Okay. Without graphing, determine how many x-intercepts the function has. So how would I do that? What's my strategy here? Yeah, we'll just look at the discriminant, won't we? Right? So the discriminant b squared minus 4ac equals what?
7 squared minus 4 half.
So that's equal to minus 60. What can you tell me about that number? Right, and we don't even really care if it's a perfect square here. We just need to know the sign of the discriminant. Right, so the answer is 0, because what's that tell me about my solutions? I get 2 imaginary solutions, but what does that mean in terms of x-intercepts? X-intercepts only correspond to real solutions, the number of real solutions, right?
So negative is 0.
Mm-hmm.
It's like if it equals 0, then it's 1.
1. Mm-hmm.
And then if it's positive, then it's 2.
It's 2.
But
yep.
Isn't it like if it's positive in a perfect square, there's 2 irrational?
They're 2 rational if it's a perfect square.
Positive not a perfect square is 2 irrational.
Yep, exactly. Yep. So the fact that it's negative means that we get 2 non-real solutions, 0 real solutions. So the answer is 0 x-intercepts. Okay, give me thumbs. How we doing? Okay. All right. How about that one? I mean, do you guys want to do this one? It's kind of the same thing. You want to do it? Okay. So what would I have to do here?
Take them all to one side.
Which side?
Left.
Left side. Good. Okay. Because I want a to be positive, don't I? So we'd end up with 5x squared minus 10x plus 5 equals 0. So I'm just going to play the same game. The discriminant in this case is equal to what?
100 minus 4 times 25. I already did the 5 by 5, sorry.
No, you're good. So that gives me 100 minus 100, doesn't it? So if the discriminant's 0, what's that tell me? Okay. One real number solution. Good. Easy, right? Okay, good. Solve the following equation. Now, pretend this one says square root, but most of them are going to say by the method of your choice. But what would your choice be here? Yeah, I'm going to isolate, aren't I? I can point to a single x, so I can isolate. So first I would square root. So that cancels the squared. And we get 6x minus 1 equals plus or minus, good, plus or minus the square root of 7. What's next? Where's it go? Good, in front of the plus or minus, good. So 6x equals 1 plus or minus square root of 7. Last step, divide by 6. Can I keep a common denominator here? I could here, right? Because it's not a complex number, so there's no reason I have to split these. Agreed? So then my solution would just be, if I divide by 6, doesn't that just give me that?
Well, if you split them, like, even though it says, like, you don't have to, but if I put, like,
1/6 plus square root of 7 over 6.
yeah,
That's fine.
that's still right.
Yeah, for sure. Yep. Yes. Yeah, I think you do. I mean, it's so here's the thing. I think sometimes the plus or minus works and sometimes it doesn't, right? It does sometimes. Yeah. So on the test, play it safe and just always split them up. Yeah, I would. There aren't very many questions on the test, so it's not that big a deal. Okay. All right. Good. Could you have another question? Okay. So everyone hear the question? Maybe someone can answer that. How do you know when you have to split it into 2 separate fractions? Okay. If it's complex, for one thing, because you have to put it in standard form where you're separating the 2 terms, a plus b times I. Okay. The other thing would be, and we'll see one like this, is if you could simplify it. Okay, now you know what, and they don't even really make you do that, honestly. Like it's like I personally feel like you should always split it if that allows you to simplify at least one of the two fractions. That's kind of my rule for myself, at least, right? Okay. So what about this guy? Solve by the method of your choice. What would we do? What am I doing first? Okay. Um, so right away, people are talking about dividing, right? Which is fine. How about if we put it into standard form first? You don't have to, but I just think generally it might be easier. So which way am I pushing the terms? I'm saying the right. How come? We want A positive. Yeah. Okay, good. So we're going to go. So that's going to give me a positive 24x squared, a negative 42x, and I already have a negative 90 on that side. And it's all equal to 0, right? And I could put the 0 on either side. That's fine. Okay. Now what? Okay, I could divide by 2. Could I divide by something bigger? 6. How'd you get 6? They're all divisible. Yeah, they're all divisible by 6, aren't they? Right? Does that make sense? Everybody see that? Right? And I guess that's a silly question. How do you know if, I mean, in this case, the numbers are small enough that we could just see that they're divisible by 6, I suppose. Okay, we'll get another one like that where I'll ask you that same question again a little later, and it'll be a better one to think about. So for this one, we just divide by 6. What if you divided by 2? Then you just end up having to divide again, right? Divide by 3. Might as well just divide everything by 6. So if we divide by 6, that's going to give us 4x squared minus 7x minus 15 equals 0, right? Okay, now we've got a quadratic equation in standard form. How would we solve this? You certainly can. That's fine. You could do quadratic formula. That's no big deal. Is there another thing you could do? Yeah, okay. I don't think we'd want to complete the square here. This would be a bad candidate for that because, for one thing, A is not equal to 1. So that makes it kind of tough. And the other thing is B is odd. So half of B is going to be a fraction. So that's really not a great candidate. It's going to work, but it's going to be way too much work. Okay, we could definitely, quadratic formula always works. Could we factor? What would the two magic numbers have to multiply to? No. What is it? Negative 60, right? They have to multiply to A times B, A times C, sorry. So it'd have to multiply to negative 60, and they would have to add to, no, negative 7, right? Because we're just using this equation, right? We're going to use the simpler one, okay? Add to B. Multiply to A times C, add to B, okay? What numbers do that? What did you say? Negative 12, positive 5, yeah. So there are magic numbers, right? So we could split that middle term, couldn't we? Right? We could rewrite this as 4x squared minus 12x plus 5x minus 15 equals 0, right? And then factor by grouping. And it actually goes pretty fast. What would I factor out of the first group? Yeah, if I make this, here's my plus sign that separates the two groups, right? I could factor out a 4x, agreed? Leaving me with x minus 3. There you go. Okay, so then we know there's my plus sign that separates the two groups. What has to be true in the second group? X minus 3 is going to be my binomial, isn't it? What goes out front? Oh, my goodness. Right?
Why the line?
Just because there's something out front. You had to just fill in the blank there, right? So then this factors into, man, I get these colors. I can never get these colors right. X minus 3 times what?
4x plus 5.
There you go. Okay, so what would my zeros be? Well, if I just set those equal to 0 and solve in my head, don't I just get, if I set 4x plus 5 equal to 0, subtract the 5 and divide by 4, isn't that just giving me negative 5/4 for my 0, right? X minus 3 is 0 when x equals 3, okay? Or I could have used quadratic formula, okay? Does that make sense? Okay, we'll do some other quadratic formula ones, so we'll just leave that one like that. Which way, you probably would, I would guess most people would do quadratic formula, right? Which way is easier? You think it is? Okay, okay, I'll buy that. Okay, I mean, if we had used quadratic formula, we would have just gotten, what, if we used quadratic formula, x equals negative b, so positive 7 plus or minus the square root of 49
Which is 7.
minus
Oh, it's 6.
4 times 4 times negative 15, all divided by, what happened there?
Scroll down.
Oh, there we go. All divided by 8, right? Where's my, yeah, by 2 times a, by 8. Okay, and if I'm inside the square root and I'm subtracting a product of involving a negative, it's positive, right? Inside the square root, if I've got an even number of negatives, remember that I can just go through and make those positive, right? So I end up with x equals 7 plus or minus the square root of 49 plus 16 times 15 is the same thing as 15 squared plus another 15, right? Does that make sense? Okay, so that's going to be 220. 15 squared is just 225 plus another 15 is 240, right? 49 plus 240 is 289. 289 is what squared? 17. Yep. So there's another way we could get those two answers, right? We're going to get 24 over 8, which is 3, or we're going to get negative 10 over 8, which is negative 5/4. Okay? Make sense?
How would you 7 plus 17 over 8? Oh, yeah. Oh.
Right.
Okay.
Okay, does that make sense? Everybody good? So either way would have worked. Okay? Okay, how about this one? Yeah, we would have to expand that out, wouldn't we? Right? So if we do that, if we expand this thing out, 3x times x is going to be 3x squared plus 6x, right? Plus another 3x plus 6 equals 1. So I'm just going to combine like terms and set it equal to 0, right? So I'm going to get 3x squared. Those guys combine to a 9x. Those guys combine to a 5 on the left equals 0, right? And now we just plug and chug in the quadratic formula, right? So then that's going to give us X equals what? You tell me what numbers to write. -9, so negative b plus or minus square root 81 minus 4 times, okay, times 3 times 5, good, which is 15, all divided by 6. Okay, so x equals -9 plus or minus the square root of 81 minus 60, 21. Okay, to me, I think personally we should split this. How come? Because I could simplify at least one of those fractions if I break it apart, right? So to me, I feel like you should do this. I feel like you should write this as -9/6 plus or minus square root of 21 over 6. So you can turn that into a -3/2 plus or minus square root of 21 over 6. Okay. Yeah. I mean, the people that wrote this textbook thought that was fine, so I guess it's probably good enough. Okay. Make sense? Okay. All right. Other questions on that? No? Okay, what else? This guy. What are we going to do? Move everything which way? To the right. Good. So if we move everything to the right, what am I going to get on the right side? Good. Equals 0. Okay, so it's in standard form. So now how am I going to solve that one? Quadratic formula, for sure, right? So quadratic formula of not x, t. T equals four times 2. Yeah, good. Okay. All over 8. Excellent. Okay. So then t equals 5 plus or minus square root of 25 minus 32, right? So what's that? -7. What's the square root of -7? Okay, good. Square root of 7i. So we're going to get 5 plus or minus the square root of 7 times I, all divided by 8. Okay, should I split? Yes. No, it doesn't really. It doesn't. I like to put it afterwards so it looks like standard form then, right? A plus B times I. Okay, now what should I do to that? I should split it. How come? Because I want to write a complex number in standard form. I want to separate the real part and the imaginary part. Okay, you definitely should do that. Complex numbers should be written in standard form. So we should write this as 5/8 plus square root of 7/8. And then notice when you write it that way, then the I is after the fraction and it's less easy to confuse where it goes, right? Okay, now notice what they did. They did not tell you specifically, you got to read the directions carefully on these. They did not tell you to write this as a complex number in standard form. So they allowed you, in this case, to incorrectly leave it with a common denominator. I am not going to mark you wrong if you do that, but I will definitely mark you right if you separate it. Even if they, like, for some crazy reason, I don't think they would, even if for some crazy reason they marked it wrong, if you split those, I will mark it correct. I'll give you full credit when I grade it, obviously, right? That makes sense? But again, if they don't ask you to write it in the standard form A plus BI, you don't have to, right? You can just leave it like that. And that really is, I mean, if they don't ask you to do it, that's probably fine. Okay. Questions on that?
Same thing. So like I noticed that they put the I on the left of the square root. So if you put it in the front and it calls it wrong, would you give us?
Now, what do you mean by the front? If you put it out in front of everything?
No, like just in front of the square root.
Oh, no, in front of the square root's fine. Yeah, that's fine. Yep. Okay. Okay, last one. When are we out of here? 35? Okay, let's see if we can get through this one. Now, let's read this carefully. Okay, I would pay close attention to this one. This is a pretty good representative example. You're going to see a problem very much like this in a couple of years in calculus also. It will look at from a little different perspective. An open box is to be constructed from a square piece of sheet metal by removing a square of side 6 feet. So it's 6 feet by 6 feet square from each corner and turning up the edges. So this is going to be a pretty big contraption you're making, right? Does that make sense? So we're cutting out, see that dimension is 6. So we're cutting out a 6 by 6 little tab from the corner and tossing it away from each of those corners. And then we're folding up the edges, okay? To create an open box. So what would the open box look like? It would just look kind of like this, right? Oh my goodness. Something like that, right? Everybody agree? Okay, what are the dimensions of that open box? What's the height? Say it again. 6 feet tall. Yeah, good. So it's 6 feet tall. What would the width be of the square base? X minus 12. Everybody see that? Because it's just going to be just this distance right there, which is X minus 6 minus another 6, right? Everybody get that? Okay, so this is X minus 12, and then it's a square base, so that's X minus 12. Agree? Okay. So that's how we bent that sheet metal to create that thing, okay? And then probably welded the sides or something, right? Okay, so it tells us if the box is to hold 864 cubic feet, sorry, what should the dimensions of the sheet metal be that we started with? Okay, so how could I set up? There you go, right? So couldn't we just do this, right? We could say X minus 12, 6 times X minus 12 squared equals 864, right? Everybody agree? Okay. And that's the equation I'm solving. Agreed? How could I solve that one most easily? Yeah, divide by 6 and then square root, right? So if I divide everything by 6, can you tell me is 6 going to go into that number? It is. How do you know? Okay, the sum of the numbers is 18. Now that rule of 6 doesn't apply, but the sum of the numbers is divisible by 3, and that is a rule, right? So we know 864 is divisible by 3. What else is it divisible by? Well, it is, but we don't need that. Dividing by 9 wouldn't do us any good, right? But how do we know it's divisible by 2? Because it's divisible by 3 and it's even, so it's also divisible by 2. So if a number is divisible by both 3 and 2, what's it guaranteed to be divisible by? 6. Aha, right? Okay, just a little mental math, little number sense stuff. So the 6's cancel. And look at this then. We end up with X minus 12 quantity squared equals 6 goes into 8 once with 2 left over. 6 goes into 26 4 times with 2 left over. 6 goes into 24 4 times. Okay, this is looking pretty easy. What do I do? Square root. So x minus 12 equals no, plus or minus 12. So then I'm going to add the 12 there, right? So I'm going to get x equals 12 plus or minus 12. So what are my two solutions? Either x equals 0 or x equals 24. Okay, are those both valid solutions? Are they? 0 is not a valid solution. How come? Yeah, that'd give you negative. If I pick 0 for x, I'm going to get a 6 by negative 12 by negative 12. Can't have a side length, can't be negative, can it? Right? So we're going to discard the 0. That one makes no sense. And the reason for that is no negative length. So our valid solution is going to be 24, right? Okay, now they didn't ask for the dimensions of the box, although we could find them now, right? The dimensions of the box would be 6 high. What would the width be? 12. And the depth would also be 12. It'd be a 6 by 12 by 12, wouldn't it? That's not what they asked for, though. They asked, what should the dimensions of the original sheet metal be? Well, the original sheet metal was x by x before we cut the corners out. Yeah, so the width of that square piece of sheet metal was 24, right? Everybody see that? Because look, we found x is 24, and x is the dimension of that sheet metal. So the sheet metal is really 24 by 24, right? And the question just asks the length of a side of the square piece of sheet metal, and that is 24. Okay? Good? Make sense? Okay, we're out of here in 5 minutes. I'm just worried we're not going to get through. So we've got 2 more to do. Why don't we do these last 2 tomorrow? And then you'll get the most of the, they won't take very long. You get most of the day to just work on prepping then. Sound good?